Let's answer this question from induction motors. Which one of the following options correct regarding a typical double squirrel cage structure used in induction motors? Asked. So the given options are: at starting, a large portion of the rotor current flows in inner gauge. Second option, at rated speed, most of the rotor current flows in the outer gauge. The purpose of the double squirrel cage structure is to lower the effective rotor resistance at the starting. The fourth option is, at starting, large portion of the rotor current flows in the outer gauge. So these are the four options given. So let's discuss something about this particular double squirrel gauge rotor construction in induction motors. So this is what the winding which will be used in a double squirrel gauge induction motor. So the rotor structure will be like this. It will be consist of two winding slots. Okay, one will be inner gauge winding, another one is outer gauge. So inner gauge consists of a rectangular shape winding conductors which will be having more cross sectional area, so that resistance will be less. So coming to the outer gauge winding conductors, the slot will be lower cross sectional area, so that's why resistance will be more. So here we can see the flux distribution. So which consists of the inner gauge consists of the flux linkages will be very more, and outer gauge consists of flux linkages are very less. So what happens here? So at the time of starting, so the rotor winding current frequency will be equal to the supply frequency, we say. So the rotor winding current frequency is equal to supply frequency. The formula is actually the rotor winding current frequency is equal to slip times of the supply frequency. At the time of starting, slip will be 1. That's why the frequency of the rotor winding current will become is equal to supply frequency. So that which will be equal to 50 Hz. So that will create the large amount of the rotor inner gauge winding inductive reactance, which will be is equal to 2πfl. So as the supply frequency is 50 Hz, which will be equal to rotor frequency. That's why XL is equal to 2πfl, which is inductive reactance of the inner gauge will be more. So that's why the inner gauge experiences high inductance values at the time of starting, because the slip value is equal to 1 and frequency is equal to 50 Hz, which will be more. So once the speed increases, the slip will be decreases. As the slip decreases, the rotor current frequency will be decreases, and the XL value also decreases. So that we can say at the time of starting, the inner gauge winding experiences higher inductance values. As the speed increases, as the speed increases, as the slip decreases, the inner gauge winding, so the inductance values will be less. Okay, so at the time of the starting, the inductance value will be more, so that the current will not concentrate. The current will it will prefer to concentrate at the outer gauge. Okay, so it will be prefer to go through the outer gauge winding conductors, so which will be designed with higher resistance values, because area of cross sectional is less, so the resistance is more. So we know the starting torque of induction motor proportional to rotor resistance. At the time of the starting, the rotor current concentrating only on the outer gauge conductors, which will be having high resistance value, so that we can say the resistance as the resistance value is more, so that the effective resistance of the rotor will be more, so the torque will be at the time of starting more. So as the speed increases, the slip value will be decreases, and current comes to concentrate in the inner gauge also. So that inner gauge consists of low resistance value, so that the torque will be slowly reduces. Okay, so this is what the picture which shows the complete analysis here. So the inner gauge consists of lower starting torque. So as the slip almost approximately when it picks up to the 50%, so that automatically the rotor the contributed torque by the inner gauge will be increases. So at the time of the starting, outer gauge will be taking more torque, and as the speed increases, the torque will be reduced. Okay, so based on this particular option, so option D is correct. So at the time of starting, large portion of the rotor current flows to the outer gauge.